All right, here's a good question. It says use a graphing calculator. We use decimals to fit regression line to the data. So here's the data we're going to use. Rather than using the dates, we'll just use the relative dates. So 0 would be when you start, and each year after that. Then they say predict the average monthly cost in 2021. Okay, we can do that. And then compare it. And then, which is obtained using the points 1, okay. And then find the correlation coefficient. Now, just one caveat, as I show you how to do this with decimals, that different regression calculators do things a little bit different. So hopefully we'll be close to the numbers that they have. So the first thing you want to do is pop this up in decimals. Okay, and so I need to type in those numbers. And we did one of these in class, so hopefully you sort of remember how to do it. So you get into decimals, then you click on the plus and hit a table. And then I'll put in all that data. So 0, 291, and 1. Maybe I'll pause the video while I put them in. Okay, so I've got the numbers in. And so rather than us determine the slope and the y-intercept, we can have decimals do that. So the way you do that is right below, you've typed in the data, we're going to type in a formula. So I'm going to type in a y, and it has to have a 1 like the number, the thing in the table up there. So y1, and then I use a tilde, that's that squiggly looking thing. And then I type out the linear equation that I think that this is going to be close to. So that's m and an x. And the x has to have that 1 on it like it does above. So y1 tilde mx1 plus b. Plus b. Okay, so right down below here, it tells me what the slope should be, and it tells me what the y-intercept should be. So when they ask you to do that here, you can write, so the thing you plug in front of the x is the slope. And the slope down here is 20 and they want it rounded to the nearest hundredth. So 20.03 I would call it. 20.03 x plus, and the y-intercept is 300.10, I think you'd call that. 300.10. Okay, so the 20.03 you'd plug in there, and the 300.10 you'd plug in there. Okay, now a couple of things with decimals here. I can't really see any of my data line. Oh, there's the line. There's the line. Let me shrink this down a little bit. So there we go. So when I look at the data, it looks like the dots are fairly close to that line. There's a couple that are a little bit out, but not too bad. There's something called a correlation coefficient, that's letter C, that says how close is your data to the actual line. It's just like how accurate is that line that they came up with. How accurate is that? And that correlation coefficient is this R value. And I think it's just the R. I don't recall if it's the R or the R squared. I'm pretty sure it's the R. You can try it. Anyway, so the R value and how close you are would be 0.9846. And they want the correlation coefficient, oh, I don't know. It doesn't ask, but I think they have you round it to 3 or 4 decimal places. So 0.9846 we'll call it. 9846. So correlation coefficient 0 means it's not correlated that well, and a positive 1 would be perfectly correlated. So getting 0.9846 means your dots are pretty close to the line. They're pretty close to 1. All right, hopefully that helps you. We're going to do all of this in class on Wednesday.